Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue on page 128 and we're going to look at quadrilaterals and their diagonal properties. Alright, remember the diagonals are drawn from opposite corners of the quadrilaterals, okay, or opposite vertices, okay. So we just connect across, across the figure, and that's how we get our two diagonals. So now we're going to look at the properties of diagonals of different quadrilaterals. And now remember, we used angles, we used sides to classify things. Now we can also use the diagonals to classify these shapes. All right, so I'm going to read on page 128. So quadrilaterals and their diagonal properties. The properties of quadrilaterals not included in the table, page 127, relate to the diagonals. A sound knowledge and understanding of the diagonals of each quadrilateral makes the classification of quadrilaterals easier and provides useful options for proofs in coordinate geometry in the senior grades. Okay. If the diagonal of a quadrilateral bisects each other, the quadrilateral is a parallelogram. It may be a rectangle, a square, or rhombus, but it is a parallelogram. Okay, so what they're saying is that if the diagonals of the quadrilateral bisect each other. Okay, let me draw that quickly. So if we have diagonals bisecting each other, so here I'll draw a parallelogram, okay, and if we fit these diagonals like that and like that, we will find that this equals to that and that equals to that, okay. So if the diagonals of the quadrilateral bisect each other, the quadrilateral is a parallelogram, okay. It may be a rectangle, a square, or a rhombus. Okay, so this can apply to many different shapes. So let's say we have a square, right? In a square, the diagonals also bisect each other, okay? Meaning that they cut each other in half. It doesn't say anything about whether these two sides are equal or not. That's not what we're talking about. We are just saying that the diagonals will cut each other in half. So both of these are valid, okay? Then we can also have a rectangle, and also in our rectangle we'll find that the diagonals bisect each other, okay? Well, actually in a rectangle all those are going to be the same, okay? Same as in a square. Okay, so all those are the same. All right, and then it can also be a rhombus. Okay, so remember a rhombus is like a parallelogram, it's just a slanted square. So it can look like that. All the sides, oh wait, we're not doing the sides, we're doing the diagonals. So there and there. Okay, and that equals to that, that equals to that. And that's what they're telling us. Okay. Right, so if diagonals bisect each other, it's definitely a parallelogram. And once we know it's a parallelogram, given more information, we can conclude whether it's a rectangle, a square, a parallelogram, or a rhombus. Okay, so that's that. Right, let's go to the next one. If the diagonals of a quadrilateral are equal, it may be a rectangle, a square, or an isosceles trapezium, but not necessarily. All right, so let's go through each one of these in turn. So now they're telling us about these two shapes. Okay, so they again say if the diagonals of the quadrilaterals are equal, well, those diagonals are equal because these are 90-degree angles. Okay, so that is the same as that, and that is the same as that. So the diagonals are equal. It could be either be a square or a rectangle or an isosceles trapezium. Okay, so let's draw an isosceles trapezium. Remember, the sides are the same length and we have two parallel lines. Okay, we have that and that. Okay. So now, if we draw in the diagonals, which would be these lines here, we would find that the diagonals are the same because this is an isosceles trapezium. Okay. But also, remember, we could have an isosceles trapezium looking like that, okay, where that is the same. And that isosceles trapezium is actually not an isosceles trapezium anymore. It is a parallelogram, okay, because these two sides are parallel and these are the same length, okay. So that's what they're saying, not necessarily, depending on what kind of isosceles trapezium we have, okay. All right, so keep that in mind. So it could be either a square, a rectangle, or an isosceles trapezium, if your diagonals are the same. Okay. Next one, if the diagonals of the quadrilateral bisect each other and are equal, then it is a rectangle. It may be a square, but it is a rectangle. All right, so if the diagonals bisect each other and they are equal, okay, so we have a rectangle, the diagonals do bisect each other, and the diagonals are equal. So it's a rectangle. It could be a square if they tell us that these two sides are the same. Okay. Right. Next one. If the diagonals cross perpendicularly, it may be a kite, a rhombus, or a square. Okay. So by cross perpendicular means 90-degree angle. So you can see this rectangle doesn't cross at a 90-degree over here or there. So it can't be a rectangle. They're saying that it could be a square, okay, because our diagonals cross at exactly 90 degrees over there. Or it could be a rhombus. Okay, so a rhombus is slanted square. Okay, and what's interesting is that the diagonals of a rhombus always cross at a 90-degree angle. So a square and a rhombus, the diagonals cross at 90 degrees. And there's another figure that is a kite that, well, where the diagonals cross at 90 degrees. So if we draw a kite over here, okay, remember these two sides are the same, those two are the same, and these angles are the same. So if we draw in our diagonals, like that, we'll find that is at 90 degrees. Okay, and this is symmetrical figure. Okay. Sorry guys, I think I got this pen into my eye. Or something's going on. All right, cool. So let's continue. If one diagonal of a quadrilateral bisects the other diagonal perpendicularly, it is a kite. It may be a square or a rhombus, but it is a kite. Okay, let's look at that again. If one diagonal of the quadrilateral bisects the other at a 90 degrees. Okay, so if we look at this diagonal does bisect this diagonal in half. But this diagonal does not bisect it in half because that is shorter than that. Okay, so one diagonal bisects the other one at 90 degrees. It is a kite. It could be a rhombus. It could be a square, depending on what the information they give us. But if they don't give us anything else apart from one diagonal bisecting the other one, we can conclude it is a kite. Okay. If one diagonal, okay, we've seen that one. If both diagonals of the quadrilateral bisect each other perpendicularly, it is a rhombus. It may be a square, but it is a rhombus. Okay, so if both diagonals bisect each other, it is a rhombus and it could be a square. So a rhombus is there. Okay, we have both diagonals bisecting each other, meaning those are equal and those are equal, and it happens at 90 degrees. Well, it's a rhombus. If we put it upright, we're going to have the same situation and we can conclude that it is a square. Okay. All right, let's continue. Now we're on the next page, page 129. If equal diagonals bisect each other perpendicularly, it is a square. So you see, they're just narrowing it down. So it's like the previous one, but if they bisect each other perpendicularly, it is a square. Okay. Because it's equal diagonals. In a rhombus, we don't have equal diagonals. So only in a square we're going to have equal diagonals, or a rectangle. But remember, in a rectangle, they don't cross at perpendicular angles, only in a square. Okay, if one diagonal bisects the corner angles into which it runs, it is a kite. Okay, so if one diagonal bisects the angles into which it runs, it's a kite. Okay, so what they're talking about is that we have a kite and we have one diagonal that bisects the angles into which it runs. So that equals to that, that equals to that. Okay. Remember, the key word here was one diagonal, okay? Because we can have, like in a square, both diagonals bisect the angles equally, okay? But that's both diagonals. If we only have one, it must be a kite, okay? That's the trick. The next one, it may be a rhombus or a square, but it is definitely a kite. Okay, so that's what they're saying. If we now have more information about the other diagonal, then maybe it's a rhombus, maybe it is a square, but it's definitely a kite. If both diagonals bisect the corner angles into which they run, it is a rhombus. Okay, so if we have a rhombus, okay, both diagonals bisect the angles into which they run. So that equals to that, that equals to that. And that equals to that, and that equals to that. Okay. Right, guys, so that's that. You can also look at this in terms of alt angles. Okay, so that angle equals to that angle, because in a rhombus, remember, we have parallel lines. Okay. Right, it may be a square, but it is a rhombus, okay? So again, depending on what the angles are, it could be a square if it's a 90 degrees, but if it's not, then it's a rhombus. If both diagonals bisect the corner angles into angles of 45 degrees, it is definitely a square, okay? So 45 degrees comes from a 90-degree angle, which we cut in half like that. So that equals to that, and it is 45 degrees. Okay. Guys, there's a lot of properties here, and you do have to learn them. So what I suggest is you run through them slowly, draw yourself the figure, look at it, see where the angles are, which ones are the same. Also, if you get stuck with this question, draw yourself the shape, because you know what it looks like. You can draw it according to scale and check, are the angles the same? Okay. The way you do this, the way I used to do this in school, if I didn't, know these exactly, I would say, right, okay, let's say they tell me that a diagonal bisects a particular angle. Okay, now which shape could it be? Well, try to think of a shape that will disprove what you're trying to show, and then you know to eliminate that option. Okay, so if a diagonal bisects an angle, let's think. Let's now draw a rectangle. Okay, but I'm going to draw a long rectangle like that, and I'm going to draw in this line over here, diagonal. Now, does that diagonal bisect the angles? Well, does that angle look the same as that angle over there? Definitely not. One is much smaller than the other one. So it can't be a rectangle. So straight away, I take the rectangle away. If I have a square, I draw in my diagonals. Yes, I can see that they are both 45. It cuts it exactly in half. So it could be a square, and so on. But guys, obviously that's your backup plan. I want you to rather learn these and practice so that you know. Right, so let's look at the example. Draw a rhombus and a rectangle indicating all the properties of the diagonals. Okay, so let's not look at the diagram. Let's draw a rhombus and indicate properties of diagonals. So Here's my rhombus. Okay. Here's my diagonals. Okay, so now what are we going to indicate? Well, we know that the diagonals bisect each other. So that equals to that. That equals to that. Also, they bisect at 90 degrees. Also, they bisect the angles where they go. So I can call this y and y. This is also y and y, and that's x and x, x and x. And I use x and y to demonstrate that it's the same angle. You see, whatever it may be. Okay, guys, so that's what we have for a rhombus. And the other one is a rectangle. Okay, so let's look at a rectangle. Okay, here's our diagonals. Okay, what do we know about the rectangle and the diagonals? Do they cross at 90 degrees? Does that look like a 90 degrees or that? No, it doesn't, okay, and they don't cross at 90, so we can't do anything there. Do the diagonals bisect each other? The answer is yes, they do bisect each other, and because we have 90-degree angle, they bisect each other exactly, and they are all the same distance, okay? So the four pieces are the same. Guys, that's all that we can say about this diagonal, right? The angles, well, I suppose we could include the angles, but all we're going to do is we're going to include alt angles. So we'll say, well, this is y, and that's y, and this is y, and this is y. Okay, and then we can call this x and x, x and x. Okay, so how did I do that, right? Well, I used isosceles triangles. Think about it, right? Let's look at this triangle. These two sides are the same, which means these two angles are the same. These two sides are the same, those two angles are the same. Same thing here, same thing there. Okay? Alright guys, so that's the worked example. Exercise 13.3. Draw a parallelogram, a square, a kite, and an isosceles trapezium, indicating all the properties of their diagonals. Your sketches should be large and fairly accurate. Okay, so guys, I don't want you to draw these not according to scale. Try your best. I don't need you to use a compass to do it, but you can draw more or less right angle and things that look more or less the same. So 13.3, it's a similar exercise to the worked example that I've just done above. So draw these figures, maybe use half a page for each figure so that you have space, so they're nice and big and you can see. All right, and indicate, like I have, all the properties of the diagonals and the angles that we have. Okay, cool guys, I'll leave it at that, and we'll continue with the next worked example on page 129 in our next lesson. Cool guys, I hope you enjoyed it, and I'll see you next time. Ciao.